for today is IG unit design. Start with, as always, a brief introduction of our company, Pilkington. Pilkington Glass Russia. We are a part of Pilkington Worldwide. Initially, it was English company. 1856. This is the date of the establishment of Pilkington in England. So 1.5 century already. We represent Pilkington, Russia. Glass factory located near Moscow. And we have a float line for basic float glass production manufacturing. And we have a coater to make soft coated glass in abundance. The capacity of the coater is about 10 million square meters of coated glass per year. Our factory is a little bit unique because it is heavily focused on export. Export areas are shown on the map in green. So the furthest point of our export so far is New Zealand. Quite far. And okay, India, Singapore, Australia, Mongolia, of course, former USSR, Central America. You will see it when I will show some projects along with in the process of our webinar today. Main product that we do is SunCool, so soft coated, solar control, and low-E glass. Wider range of characteristics, and the naming. For those who don't know, SunCool is the trademark. Yeah, that is the typical name of our glass. Then comes color, if it has any color, and then two numbers. First one is light transmission, so how much light is going in, and second one is solar factor, so how much solar heat is going in. Of course, we will be talking more about SunCool and so on in the course of our webinar. So now we may finally go to the meat of it and start talking about IG unit design. So done with introductions, let's go for an interesting thing. From the first look, the design of IG unit, okay, what is this? Two glass, spacer in between, assemble, and go ahead. If we're talking about architectural IG units, however, which are going on commercial projects, big size IG units, so high-rise towers, skyscrapers, and so on, things become way more complicated. And here I will just show you a brief list about what is important, what things are important for IG unit composition. First, of course, are the parameters. So glass parameters, of course, they can be calculated quite easily on our website, for example. These are visual parameters, light transmission, light reflection, solar control parameters, and of course, U value. All of these are basics. When you are going on a project, or we are going on a project, usually there is some kind of, I don't know, technical specification in accordance to which we need to choose the proper parameters and put them into the calculator. That is an easiest part of all, although as you will see further, it has a lot of stones underneath. Then comes the loads. Loads is some kind of forces that affecting IG units. And we will start with them. Because at first, when you're going to talk about something, you need to define the basic parameters. So loads are usually wind, from the wind, climate loads, and that is the most usual cause of optical distortions on the facade. And of course, some kind of special loads like human body impact when someone jumps on your glass and so on. These loads require dedicated calculation, which can be performed only with special software and special knowledge. So for this kind of calculations, you should address usually to us, the glass manufacturer. Then comes a very important topic about IG unit size and geometry, because in IG units, size really does matter, because it affects the cost, as always. It is always should be compared to the processor capabilities, so meaning glass IG unit manufacturer can actually make IG units that you designed. Sometimes it's really a hard one. And then, of course, size and geometry affects how does your building will look like in real life, and not on the design stage, not on the computer render. We'll also see the difference in the future. Then here in the size and geometry, in here lies the core of the design, because from size and geometry of IG unit comes glass thickness, spacer width, and with that comes weight, cost, and so on. IG unit geometry and IG unit composition. Then we may take into account special requirements, for example, safety, security regulations, and acoustics. For example, if you're designing an IG units for airport, acoustics is a must. Also goes for the hotels and other kind of special buildings. And in the end, when we have a rough estimation of what our IG unit composition will be, we need to think about special features. If it has some kind of paint on it, some kind about silk screening, ceramic print, will it be a standard aluminum facade or will it be a structural facade system? Then we need to think about silicones and many, many things from the production IG unit manufacturing perspective. Finally, after all of this is done, you're going to processor and asking him whether, okay, can you make it? And if yes, then how much? This is a short list. Behind every point in this one lies quite a deep pit of problems, specialties, and so on and so forth. Today, we will be going to dig a very shallow from the top. And if you're going to go in depth, then okay, you can either address me or we can go and arrange for some kind of specialized webinars, some future sessions, I don't know. So what forces are affecting IG unit, how they are calculated, and where to look if you get a calculation results, for example, from us. If you're building some kind of tower or something like that, the first thing comes to mind is the wind load, because of course wind blows and it can affect your glass in fundamental way. To illustrate that, here is the picture. It happened in Yekaterinburg, as far as I recall. And here you have a piece of balcony which have been torn away by the wind. The interesting thing here, it has been torn away and not smashed inside the building. That is because wind load can be either positive, so meaning wind is blowing into the glass, or wind can be negative. So if, for example, the geometry of your building is complicated and then the wind is blowing and then the force of the speed of the wind is changing rapidly, then you will be having areas of negative pressure, which will be tearing your pieces of your facade, of your IG units, or your balconies for that case, away. not into the building, but out of them. So here is a good example how this whole construction, not the IG unit, but the PVB, has not been properly calculated or installed, so it has been torn away, and thanks God, it hasn't been killed anyone. So wind load is very important, but wind load in accordance to our norms, and there are many websites which you can see the wind load for each part of the world, not only for Europe or Russia or whatever. Wind load is calculated when it is maximum. I will tell you why it is important. Because when you are estimating a wind load, you are taking it into account the maximum wind, which is happening roughly once per 50 years, so twice a century. That is very rare, but you need to be sure that your IG unit and the glass in it will withstand that load and will remain whole. So that is why you need the wind load, to understand whether the glass will break or not. That is called peak load. Peak meaning пиковая нагрузка in Russian, and peak load, so maximum. That is in short about wind. Second one, and this very important one, is climatic load. Climatic load is not, usually it is not about glass breakage. If we are talking about architectural units, of course, meaning tempering, laminating, thick glasses, so all you usually do for architectural projects. But climatic load in this case is mostly affecting your visual look of your building, the visual look of your building. How will your building look like? Okay, what is the climatic load? When IG unit is assembled, the volume of gas inside it is constant, meaning it should not change during IG unit lifetime. That means the IG units are assembled in production site, let's say at the temperature of about 20 degrees, and if later on they are put on the facade, and on the facade they will get heated up by the sun. Then the air inside them expands. The pressure rises and the glass are forced to bend. In case of heating, the bending is outwards. If it is in the winter, IG unit gets cold, the bending is going to be inwards. And for example, if you assembled your IG units at the sea level and then installed them high on the mountain, the difference in the atmospheric pressure can be also quite huge. So climatic load is something which affects your IG unit every day, not once in 50 years, mind you. And that load is changing from day to night, from summer to winter in a slow way. And usually climatic loads itself, it's much lower than the wind. But the wind is again about whether your glass will break or not. Climatic load is about how your IG unit and how your facade will look like. Next one is the snow load. I don't think we need many comments here because, of course, the picture speaks for itself. And of course, snow load is for horizontal or close to horizontal surfaces, cold climates. And again, when the snow is on top of your roof, if the roof is glass, then the most important thing you need to do to be sure that glass will not break. Again, break or affect your facade visually. And finally, we have a human impact. That is a very rare load case when somebody tries to jump out like a Benedict Cumberbatch here. But of course, such pictures are not possible in real life. The load itself is, and the calculations for it are quite unusual. And this type of calculation can be performed only on special request if you know that you need it. So we will not be really touching or taking it into account a lot. These are three main load types. So wind, climate, snow. I understand that, yeah, please forgive me that the introduction was a little bit boring and technical. Later on, it will be more fun when we get to the pictures. And we get to the first question. Which norm standards you are using for calculating of wind loads? That is highly dependent on for which countries we are which country we are doing the calculation. We are always trying to use local norms. For Russia and many former USSR countries, we are using standard GOST and SNP norms. For Europe, we are using European norms, and we are deriving it from the website, the basic climate loads for the website. For example, for Singapore, we're using ASHRAE. For Australia, ASHRAE 2 and NFRC. So everywhere we're trying to use local norms for estimation of wind loads. Frequently, if we had a big project, the project has itself some kind of making itself a small maquette, and then is blown in aerodynamic tube. So we can derive wind loads from there. I hope I answered your question. So we can either take wind loads that client is giving to us or try to estimate them on our own. Okay, we have understood a little bit about load types. So we take an IG unit, we apply all of these loads onto it, and what do we get as a result of the calculation? For each glass, we're getting two numbers. First number is maximum stress on glass, or in Russian, напряжение. Maximum stress gives you an idea if the glass will break or not under the load combination. For each glass type, for example, standard float glass or annealed, heat strengthened, tempered, laminated, here in the table are maximum allowable stress. So this is equivalent of maximum force per area the glass can withstand. So the glass can survive. And we need this number when we are making a calculation to determine whether glass will break or not. So first, stress. Second one, glass bending. How much the glass will bend under given loads. And here comes the tricky part. When we are doing a calculation for wind load, remember, this is the maximum wind once per 50 years. So glass bending in this case will be very big if we calculate it with the maximum wind, of course. But the question is, when we are looking at the calculation, we want to see two parameters. First one is whether it will stay, but the second one is how the glass will look like, how good will the facade be, actual facade. And for that, we need to look at the bending. But if we calculate the wind, which is happening once per 50 years, and look at the bending, we will never get a correct picture for understanding how our facade will be looking in real life. So, because, okay, Maximum wind is usually looks like this. When you are blown away, you will not be looking at the facade at this time, of course, and saying, too much bending. No. And for that, I've made a very simple table at which type of, at which parameter you should be looking when you're seeing a calculation for each specific glass combination. If we are calculating peak loads, so maximum forces combined, we should be looking at stress. Will the glass break or not? If we want to understand how the facade of the building will look like in reality, we should be looking at bending, but we should be calculating with climate load. You see, it's like a puzzle. Many things interconnected going into place. I'm trying to simplify that for you. I hope that I'm successful at that. So actually, what do you need? For your buildings, you actually need two calculations, not one. First one, you need to understand whether your glass will survive. And that is the calculation for maximum wind load, climatic load, and everything else combined. Great. But the second calculation with just the climate load, so just normal outside conditions in winter and summer, will give you an idea how your facade will look like in reality. If we're taking into account snow load, you need to look for both. Of course, because snow is either can break your glass, and your glass should not bend too much if it is overhead of you, for obvious reason. And here is the example of calculation. First one is under peak loads, maximum ones. So right here. And yeah, mind you, IG unit size and composition are all the same. So what do you see? If we'll be looking at the top of the table, so under maximum load, we see, okay, very big deflection, very big glass bending. So this composition should be better, right? This one. In fact, yeah, under the maximum load, yeah, but in real life, no. In reality, if we will be looking for how these IG units will be looking like in real life, looking at the maximum deflection, this combination is better. So why am I focusing on this for too much in the beginning of our webinar? First thing, to give you a rough idea about loads and calculations, because we will be using them further down the line. Second one, I'm focusing because this is very important. And not only we, meaning Pilkington, but our competitors are also usually giving this type of calculations. But you need to understand where to look. And in the design of IG unit, it is very important to know, as basically everywhere, it is very important to know where to look for a proper numbers. Okay, I think the hard part is done. Dear colleagues, if you have any questions, you can just post them into the chat section. Don't hesitate to do so. If you have a question which is quite long and you don't want to spend a lot of time to writing it down, you can just, turn on your microphone, video, and ask a question personally. It would be very good. So any questions so far? Okay, when no questions, it's can mean two things. Either A, everything is understood, or B, no, I was too bit technical and nothing is understood completely. Okay, I hope down further we will clarify. Let's talk, okay, we are basically done talking about design for maximum force, maximum load combinations. And now we will be going to more mundane things like how to make facade look good and what can you encounter in the process. So here you see, I like these pictures. These are very beautiful facades. I really do believe that at the design stage, they looked great. I think they are, but in reality, you see many optical distortions on each of them. And that is the usual situation. So to make your building look good, three things need to be considered. Proper IG unit design, in design, meaning IG unit composition, glass choice, so on and so forth. Then we need to have a good processing of the glass, because even the best designed IG unit can be done wrong and then everything goes astray. And the last thing, which is not really obvious from the first glance, is the comfort inside the building. And that is where human factor is going into full swing and affects how your building will look like. So we will be looking at this piece by piece. In terms of visual look of the building, very important from the first stage to think about the outer glass and the coating. From visual point of view, most important parameters are light transmission and light reflection, or light transmittance and light reflectance, whatever you may call them. Here you can see two opposite sides of that. First one is the project in the bottom right. This is the Bank of Astana on our glass. You see, glass is very transparent and with very low light reflection. In here, you can see very clearly inside what is inside the building. So far, it's under construction, so nothing really beautiful to see there. But in terms of facade uniformity, you can see that non-transparent zones of the building can differ from transparent zones quite drastically. That is because with the high light transmittance glass and low light reflectance glass, it is impossible to make the facade look uniform. So transparent and non-transparent part will not be looking alike in any case, even you get the color of the enameled glass right. Directly opposite is our very dark glass, Suncool, and this is the Academy building, Academy Business Center in Minsk. Here is Suncool 30.16. So darkest glass in our arsenal. And then here you can see that, okay, transparent zones and non-transparent zones are almost exactly matching because light reflectance is higher and light transmittance is much lower. So dark reflective glass helps you to create uniformous facade. Transparent non-reflective glass helps you to create very transparent facades, but there will not be uniformous whatever you do. So depending on the architect's choice, or I don't know who is making a decision maker's choice, you need to consider different options for glazing. With this, you may think, okay, then reflective glass is good because uniform facade is great. The question is yes and no. There is no recipe like, okay, Lower light reflectance is very good, high light reflectance is bad. It all depending on the tastes and choices. But the one disadvantage of the highly reflective glass is that the higher the reflectance, the more optical distortion can be seen on the facade. And here we're going to the very important part of IG unit design, mainly the size and shape. I like this photo, really. Okay, of course, the glasses are highly reflective, and by the bending of the glass, you can see that this is clearly a distortion from climatic load because it's very uniform. It's like a bubble, beautiful bubble. So here, we need to think about height to width composition, height to width ratio. And there goes the first rule. The more IG unit, the closer IG unit shape to square, the bigger optical distortion you will see. Because if the IG unit is square, both sides are equal. But the maximum bending of glass from climate loads, meaning from expansion or shrinking of the gas inside, is determined by the shortest side of IG units. If both sides are equal, then the bending is maximum. If not, then like here, this one. Okay, just hold on. Where is my painting device? Okay, here. You see, let's compare these two IG units, 1 and 2. This side is equal on both of them. But this one has shorter side, and this is like square. And the bending on this IG unit on the top is clearly less than on the bottom one. Of course, everyone wants IG units to be as big as possible, so have a maximum area. But please consider that maximum area, here being a square with the lesser perimeter, is not always good. So the good way of IG unit design, if height to width ratio is 1 to 2, from 1 to 2 to 1 to 3. 1 к 2, 1 к 3. This is an optimal ratio of height to width in IG unit because it offers you minimum glass bending with maximum area. Mind you, it also is very good for IG unit manufacturer because this height to width ratio is best for tempering. The easiest way to get tempering regime for your glass is when your glass is having the size or shape like a rectangle with one side is twice shorter than the other. Next slide is an example of the square IG units on a facade. Here we have, you see, everywhere is the optical distortion from the climate load, and everywhere it's about the same. The interesting thing here is, please notice that here in the bottom you see a lot of distortions. So facade is not looking very good, right? But on the top, IG units are close to ideal. Are they different from the bottom ones? The answer is no. But the difference is just on the photo because the bottom ones are reflecting something of geometrical shape, so meaning opposite building. And the top ones are reflecting nothing, just a clear blue sky. And that causes some funny stories when you are building a skyscraper. Then the client comes to you and says, you see, on the top, IG units are very good. But on the bottom, a lot of distortions. no good. Please take your IG units back. Of course, then can create some kind of tensions. In fact, IG units on the top and the bottom can be, and usually are, the same. The difference is only in reflection. So in here, my advice is follow the height to width ratio. Do not make IG units square. And if possible, because in the bottom part of the building, usually IG units are bigger than on the top. So pay most attention to the IG units which are located in the bottom side of the building, where they will be reflecting something. Here is an example of a proper IG unit design, and I've took this slide from the IGUs Architectural Bureau, our very good friends in Singapore. So with their permission, please take a look at the facade. Here, all of the IG units are rectangular. Like the transparent, sorry. Transparent zone is long, is high, and enameled zones are positioned crosswise, but they're all maintain this ratio of sides of IG unit. So this is an example of a very good and thorough design from the design stage. They are supporting the look of your building visually, and they are very good in terms of minimizing optical distortion on the facade when it comes to real life. Some good pictures from real life. This is Lebedevo Office Center in Russia. And yeah, here we can finally talk a little bit about our coated glass. And this is the Suncool 7040 temperable version. And the glass is very transparent, and it is famous for its very, very low light reflection. 10% is actually lower than your normal IG unit made from float glass. So it is coating is not usually making glass, cannot only make glass more reflective, but it can also make glass less reflective than the normal float. And in here, you can see that height to width ratio is very good, and it supports the look of the building. And you see it reflects a building, the reflection is also very good. So good processing, good design, good architectural solution. All of this, and good glass, of course, yeah. All of these things combined, creating you a very good looking facade in the end. Next example, another glass. It's a Platov Airport, Rostov-on-Don, built for football championship. And you see, IG unit shape is also rectangular, and minimum optical distortions can be seen on the facade. The airport is itself very beautiful. If you want, you can see more pictures in Google or Yandex for that matter. It has a very interesting roof. And the design idea was to use a glass with maximum transparency and create a very visual, good-looking airport. I think last picture about IG unit shape is our two projects in Latin America. All glass are from Pilkington, Russia. This is Nuevos Horizontes Office Center in Honduras. You see, the transparent and non-transparent zones, again, arranged in the same order as in IGUs project. So very good design. And here is the Insurgentes Office Center in Mexico. Also very good reflection, very interesting glass. Okay, photos are not rendered. Right one, absolutely not. Left one, actually, I don't think so, because all of these are made on the cameras of our colleagues. The next photo is rendered a little bit. This one. And with here, there's some kind of cheat, because you get triangles here. So the shape is not really resembles to square or rectangular, it is triangle. And with triangle shape, you get very few optical distortions from the climate. But if you go for triangles, please beware that you need to be sure that your IGUnit processor can do the tempering of triangles on the same level as your design. And this is the Windesheim school in Germany. And the glass is not from Russia, it's German one, Pilkington, Germany. But you see, facade, good looking, but if you take a look at the reflection, not so much. So triangles are usually very good at climatic load distortions, but you need to have a very good processor to make them right. The question is, difference between German and Russian version is similar, or is any visual technical difference? The coating is similar, absolutely. There is the difference is in the base glass. German glass is a little bit greener than ours because we have a very good sand. So if you are using Pilkington, try using either ours, preferably ours, of course, or German, but not mix them together because the shade of green can be slightly different. That is the usual stuff which applies for any glass manufacturer. If you are taking glass from glass manufacturer, I mean us, AGC, Guardian, Saint-Gobain, whatever, PG, take glass from one factory, not from two different factories, because the glass there can be sometimes very obvious glass difference, especially if the glass is 8 mm or thicker. So the question is, what IGUnits were used in Lachta skyscraper, St. Petersburg? Oh, that is actually for Lachta Center, we use a mix of IGUnits. Coating is not ours, but part of the glass has been produced in Germany. Part of the glass for Lachta Center has been produced in a Russian glass company, St. Petersburg. Those time I've been working for a Russian glass company, so I know. And they were very famous because they have unusually strict quality requirements in terms of iridescence or anisotropy. But I think I will better leave the detailed answer of this question for later, because it is interesting, but not directly related, I think, to our focus. Okay, colleagues, please don't hesitate to ask questions. Any questions you like, feel free to go ahead. Russian, English doesn't matter. It's only a matter of your preference. So this is an educational webinar after all, so again, don't hesitate. I think was done with AGC glass. Yeah, I believe that too. But the coating, the coated part of the Lachta has not been done in Russia. RGC St. Petersburg has been doing mullions, glass mullions for this. So it's laminated glass of 4 to 5, 10 millimeter glass, very strict lamination, heat strengthened. Yes, definitely it was not Pilkington, although we participated. The most difficult building I've been designing during my glass career is the Evolution Center in Moscow City. So this is a very distinct building which looking like a DNA spiral. very distinctive one. So you can go and check the visual of that. Evolution tower. And it was very tough. The question from Rain, I hope I pronounced it right. What to keep in mind if those new window for private houses? Oh, yes. A little bit down the line. So for private houses, I will be talking a bit further. If I will not answer your question, then please remind me in the end. That is a very important one. But colleagues, thank you for asking questions. Go ahead, don't hesitate. I like questions. It's the best way if we are both to speak, not only me, because discussion is always better than, I don't know, me speaking the whole time. Okay, go ahead with the questions, and we will go ahead with our specifics. The thing is that, okay, we have designed transparent zone, non-transparent zones, chosen the color for enameled glass, then went ahead, and in the end we may receive that the IG units, which have the very same composition for transparent and non-transparent zones and should be looking similar on the facade, in fact are not. On the photo, you will see that non-transparent zone here clearly differs in optical distortion from the transparent one, but the size is absolutely the same and the facade is absolutely the same. Why is that happening? Yeah. Okay. Was that a question?
Yeah.
Yes. Good morning. No. Okay, colleagues. I think voice questions we will leave for the last part. Now, please go on into the chat. So, as I've told, IG unit size of transparent and non-transparent zones, same, but distortions are different. Why is that? That is because condition for transparent and non-transparent zones are different. Imagine if you're, okay, now it's a summer, hot. For transparent zones, outside you get sun and your street and so on, outside air. Inside you have some kind of, I think, air conditioning, so the temperature is quite stable. But for non-transparent zones, outside you have normal air, but inside you have heat insulation. IG unit get heated by the sun, and remember there's a painted glass inside, so it absorbs a lot of heat. And non-transparent zones, okay, if you heat it too much, you need to drop the heat out. But non-transparent spandrel zones, in fact, they usually cannot drop the heat because inside there is a heat insulation. So IG unit cannot dump a lot of heat there. And if outside you're using low E glass, that it cannot really drop the heat outside because low E coating prevents. That means in the summer, non-transparent zones, spandrel zones, are overheated usually. So they heat it much more than the transparent zones. But what happens in the winter? In the winter, transparent zone, it gets heat from inside air from our heating systems. So it's more or less, has a more or less stable temperature. But in the non-transparent zones, it doesn't get heat from inside because, again, heat insulation. So in summer, it is hotter, much hotter sometimes. In winter, it is much colder. And that means that pressure difference will be much bigger and the bending of the glass will be much bigger for the non-transparent zones. And you can end up with the picture like this, where on the first glance, by design, everything looked normal, but in fact, it ended up that it is not normal. For IG units in non-transparent zones, several rules. First, it is good for you to use thicker glass as an outside. I mean, thicker glass than the inside glass. So outside glass thickness is bigger than the inside. So the inside glass will bend more. The second rule is that it is good to reduce the spacer width of the IG unit, simply because the less spacer width you have, the shorter the spacer, the less air, the less gas you have inside, less optical distortions. So from that perspective, we can think, okay, two rules. First, thicker outer glass, good. It will bend less. And not that wide spacer, also good. But in fact, some of these are not. Okay, colleagues, a little bit later on with the questions. But, okay, we've determined with the glass thickness, general rule, thicker the glass, the better. Always works, mind you. But if our spacer is too short, we may get directly opposite effect in the winter. Remember, in the summer, our glass expands. In the winter, our glass are bending inwards. And they may end up that the winter is so cold and the air shrinks so much, or gas for that matter, that the glass will be touching each other in the center. See here, rainbow spots. That means that in these places, glass are either touching each other, two glass, or they're less than 1 millimeter from one another. So almost touching. And that is a very bad thing, because that means that glass design, IG unit design, glass thickness, and spacer width, some of them have been chosen incorrectly. And that also is a very frequent problem for private houses, simply because I'm referring to the question that Mr. Ryan was asking. That is the problem because private houses are usually not heated in some winters. For example, you have built a house, you have put in their windows with IG units, and private clients like them big. It ended up that the house has not been heated during winter. If it is not heated, then temperature difference between production and installation of IG unit is very high. Temperature difference is very high. So glass during the winter will touch each other, and this can also result not only into rainbow spots, but to permanent damage of the coating, like shown on this picture. This is the same IG unit, only a little bit later. So in private houses, very important is to remind, or if you are selling to private, to private individuals, it is very good idea to first think twice about design of big IG units, because they have a tendency of, if the house is not heated during the winter, they have a tendency of glass touching each other. Second one, it is good to think about your agreement with the private customer and underline there that, okay, after the IG unit installation or window installation for that matters, the conditions should be made in accordance to requirements with the European regulative standards or Russian standards for that matter, because our GOST is clearly states that under which conditions IG unit should be used, meaning no negative temperature, no, the inside of the building should be heated. So you should think about IG unit composition very carefully for big size. And second one, you should not endanger yourself, I mean, save yourself by underlining the conditions for the window in advance when you are signing an agreement with the customer. These are two main things, in my opinion, if you are building a cottages. Okay, now let's go to the questions. Do you have a web calculator for noise, RV plus CTR values together? Carmo, we don't have, okay. We have an acoustic calculator, yes, but it is a software we have purchased and it is for our use, meaning we can make a calculation for you, no problem, upon request, easily, but you cannot use this software. For that matter, I can give you later on a link to our website. There can be seen an acoustic values for many IG units, for the common ones, but not for all of them, unfortunately. So you will find, you may not find what you are looking for all IG unit combinations.
So you're speaking about spectrum, don't you?
Yeah, in spectrum, some cases are listed, some cases are not. Please understand that for our spectrum, it is not really calculating values. It is using a values we have been tested, or the data we have acquired, and if the IG unit composition matches, then it will provide the acoustic reduction value. If it is not matching with anything in the database, it will not provide. But we have a software in SUL special, which can calculate acoustic values for different size and compositions. Just calculate. So with this software, we can calculate anything. So if you haven't found this on the web calculator, please address us. We can calculate it for you. No problem with that. Second question is Agneta. Lahta Tower supplied with Saint-Gobain glass Planetherm 1 and so-called light SKN 0.76, both on extra clear diamond substrate. Thanks a lot for the info. Now, I was not aware that in Lahta Center what used the Saint-Gobain was used finally. I've participated only in the glass mullions myself. But anyway, Agneta, thanks a lot for the explanation. The question from Tina, is there a suggestion or norm of how to install dark colored curtain rolls to the large glass facade to avoid thermal stress? The best way, temper everything and you don't have to be worrying about thermal stress at all. So tempered glass, way to go solution. With tempered glass, you can use whatever you like. No thermal shock, never. Distance between curtain wall and glass. Glass facade parameters. Okay, 0.30, thickness. Okay, Tina, I think I'll leave the question for the Q&A part, okay? Because it's quite specific. Please remind me. Okay. So where we ended up, that glass thickness and spacer width. For summer, for winter, different. For transparent, for non-transparent zone, different yet again. Basically, that's repeating what I've already said. Spacer width, yeah. But we have another factor to take into account. And that is tempering. Tempered glass, by the standards, can have the bending on its own. because tempered glass is not as flat as normal annealed glass. That is because of the heating and cooling process. For different glass, different size, different thickness, quite different. But by the book, by the standards, tempered glass can have its own bending. And that, when you're thinking about IG unit design, can also needed to also be taken into account. Mind you, this is not a defect. This is a measure regulated by the standards for tempered glass. So kind of normal. Although my opinion that tempering glass standards are way too lenient to the processor in this regard, because the allowances for the bending are too much. So glass thickness, spacer distance, height to width ratio, plus tempering. All of this combined. For those who are not dealing it on a day-to-day basis, can be quite difficult. For that matter, we have developed our brochure for the recommended glass thickness and spacer width, depending on the IG unit size. I will be not going into a lot of numbers now. Better if I will then, okay, you will either send me a letter for this brochure, or I will send it, of course, to Simeon. You can ask him about this. But in this brochure, you will find in-depth explanation about how these tables work, how they should be used, why numbers are what they are in those tables. But this brochure from us helps you to very quickly and very easily estimate, not make final, really, your composition for your IG unit. Because all of these we've been trying to take into account when making these tables. For those who are not dealing, again, day-to-day basis, very useful. One closing remark. No, I think I'll make this remark later. So, glass thickness, spacer widths for different types of kinds of climate. This one here, an example for a hot climate. You may find it later on. Or I will do what I will do in the end. I will put it. I will download this brochure into the chat, so you may download it directly from Zoom. Will be very convenient, I believe. Okay.
This will be the best way, I guess.
Sure. I think so. Excuse me. Okay. So all of these things, ratio, thickness, loads, can be calculated, estimated, or just estimated by you with using our brochure. But please don't hesitate to contact Pilkington in case you are designing something. From your side, you will get all the technical help we can give you. From your side, we will know about the project. So it's a win-win situation for us, I guess. And the chance for us to utilize our technical skills, and for you to rely on them and get rid of many problems in advance. Okay, after design, after IG unit design, we need to think about processing. We are closing to an end. I took a bit further. Okay, processing. First thing you need to consider is tempering. With tempering itself is a quite dedicated process, one of my favorites. But today we'll be talking about it shortly, because from the tempering, you can get, first thing you see on many buildings is roller wave. The happening of this is because in the tempering furnace, glass is heated to the temperature beyond its softening point. And when it gets cooled down, it remains with these bendings, with the roller waves. The general rule about the roller waves, there are two. First one, use thicker glass. My advice, if you're using dark or coated or reflective glass as an outside glass, and you are going to temper it, do not use 4mm glass, never. Go for 6 at least. That is because for 4mm is a very thin glass, and it is very difficult to be properly tempered without roller waves. 6 glass is way better. So for outside, if you want it to look good, and if your glass is dark, either or reflective, go for 6mm tempered glass, not 4mm tempered. If you're not tempering it, okay, no problem. Second rule is that when you are designing your IG units and then addressing a processor, tell him where is the height of your IG unit and where is the width, simply because that your roller waves and the glass should be positioned in the furnace such that your roller waves will be parallel to the surface. In this way, they are much less noticeable, because if someone walks by your building, if they are perpendicular, the reflection will always be distorted. If they are parallel, much better. Here is an example of the thing done wrong when the facade has an optical distortion perpendicular. So the picture is not that pretty as on the previous one. Okay, so proper design combined with the proper tempering. So in order to avoid use thicker glass, go for a good processor. And third thing, which may help you, if the processor is certified by glass manufacturer. All of the glass manufacturers doing such things, meaning we are frequently visiting our processors, see how they work, certify, help, then drink some tea and get out, as usually from their side. So, and the certificate of the processor. In the extreme case, what you can get on the facade is something like this. Right here. Do you have any idea what is this what is actually in the reflection? No? And this is the building that stands in the very center of Tashkent in Uzbekistan. It's a presidential library or something. Okay, actually the thing in reflection is this column. You notice a little difference between these two, yes? So that is how your processing and bad design can change the reflection of the surroundings. These IG units are manufactured by Chinese company. Okay, now you get the you can see the lower end, right, of bad processing. Actually, here on the picture, you can see a roller wave with the tempering lens distortion combined. So they produce such funny results. I have quite a big collection of these horrors because I've been collecting them for 15 years already. Okay, next up on the list. Edge effect. So edge distortions on the tempering glass. While roller wave is avoidable, edge defects or edge effects, okay, edge kink, it's called edge kink. Edge kink is unavoidable because when you get the glass tempered, you will always have some kind of distortions on the edges. General rule about glass thickness also fully applies here. Thicker the glass, better the results. Because thicker glass has much less bending from climate load, and it usually has much less optical distortions left from tempering. So while roller waves can be avoided, edge kink again is unavoidable because of the tempering furnace, inner workings, inner construction. The thing to consider here is also, we're returning to the beginning, is light reflection of the glass. Remember, the more reflective the glass, the more effects, distortions, whatever else you will see on it. So if we're taking both facades of equal quality, one of light reflection of 15, another of light reflection of 30, then you will get two absolutely different facades from visual point of view. Again, less reflection, less to worry about distortions. So thicker glass, lower reflectance, proper design, good processing. 4 things. Again, from the horror collection, you can get something like this. A very unique facade, which in my opinion has all of the things I've mentioned and a few more. This is very reflective glass in the winter, unheated building, very big distortions, improper positioning of roller waves, proper positioning of the glass in terms of roller waves. And in the end, you have here some distortions from the facade clamping. So just about everything which can be done wrong is combined on this facade. Yeah, and very thin glass. Perfect combination, ideal storm. That is about processing. Last thing to consider, this is more like an information and funny thing, is the comfort. And that is more a design. First, before it was more about IG unit. The comfort is not only about IG unit, but about facade and building general design in general. How do you think comfort can affect the building? In a way like this. These are 2 photos of one of the center of the business center Avilon in Moscow. One is taken when the building was just built, the left one, and this is the more or less modern photo of our days. You see the difference, right? On the facade, very clear. I really doubt that architect designed his facade to be a collection of blinds of different sorts. Why is it happening? Because if you designed and build a building and the people are not comfortable in the building, they don't feel comfortable, they will use some kind of protection, because comfort is, when you're working, comfort is very good for you. And there, people are starting getting innovative. So blinds, curtains, whatever kind of solar protection devices they can get their hands on are used here. But actually, this example is more or less, let's say, civilized, because the blinds are more or less similar, although color difference is clearly noticeable. We can get an example, it's my favorite, of uncivilized solar protection. So aluminum foil number 1, aluminum foil type 2, blinds, curtains, I don't know what. So this is the lower end of the facade. And all of these things, this is the Grand shopping mall, Mebelny Center Grand in Moscow. The picture has been taken by me several years ago. And now it looks exactly similar. No changes. And all of this is happening because solar protection is clearly not enough, clearly inadequate. For the best solar protection and for the best comfort, I advise to use special glass, soft-coated, solar control, and low E. The main feature of the glass, on the Avilon, there is a body tinted blue glass. Here, no solar protection whatsoever, clear float all the way. But if you're using specialized glass, you can make it, if you use a special coating, you can make your glass selective, meaning that it will transmit a lot of light in the visible spectrum of the sun, while not transmitting a lot of solar heat, reflecting it back. Exactly why we have in our naming, in SunCool names, two different numbers. First one is again how much light transmission. Second one is solar protection. You see their difference for almost twice in most of the cases. Yeah, and that is the list of the glass that we are producing. They are all selective. They all have a very good U value, or R value for that matter. Light transmission in the changes in the wide range. Light reflection from 10 to 38 changes even wider. So it's depending on your taste. And all of them, apart from the standard low E glass, are solar, have some degree of solar control. And the last thing I wanted to say for today, then all of these things can be tried and estimated in advance using specialized software. Even the level of comfort inside the building, right here. Apart from energy efficiency, good U value, solar protection, you see there in the picture 3 different facades with 3 different glazing types. And apart from that, comfort also can be estimated, and the things which I've shown above can be prevented at an early stage. Moreover, if you're using specialized glasses, the energy efficiency and the return of investment can be estimated for the project of your choosing.